Okay, problem 1048. Find V out in the network, and it's a transformer problem. Alright, the first thing we're going to do is create a Thevenin circuit. Bring this circuit, basically bring this whole circuit, this side of the transformer, into this side. So the first thing we're going to want to do is find the Thevenin voltage here, and the equivalent Thevenin resistance. So first we're going to... Okay, so we cut out the rest of the circuit, just a little bit more room. So we find out right away that this V Thevenin right here is the same voltage right here, because no current's flowing through this this wire right here, which makes this really easy to solve. So we have 6 amps going through this whole thing. Current doesn't divide anywhere, so the V over that resistor right there is 6 amps times 2 ohms equals 12 volts. This means that our Thevenin voltage is 36 plus 12. That's an ugly 3. Okay. Let's see what I did next. Okay, so now our Thevenin voltage is 48 volts. Now for our Thevenin impedance, we're going to open the current source, short the voltage source, which leaves only two resistors impedances. So our Z Thevenin is 2 minus 2J. Okay, so now we want to fold that into our circuit. So here's our Z Thevenin, 2 minus 2J, and our Thevenin equivalent voltage, 48 volts. So here, to bring the Thevenin circuit, equivalent circuit, into our circuit going this way, we want so the equivalent impedance is going to be our impedance times n squared, and our voltage is going to be V times n, and n has to do with this ratio right here. So the quick and dirty way I found that to solve these is whatever direction you're going, you make that number in the numerator. So since we're going this way, we're going to take 1 over 2, so n is going to be 1 over 2. But if you're going the other way, then you'd have 2 over 1 if you brought this circuit into that. This makes the calculation really easy, really quick. So our okay, so here's our equivalent voltage and impedance once we bring the Thevenin into our circuit. Okay, so now our overall circuit looks like this. Now what we want to do is we want to find the node voltage here, and the best way to do that is if we just combine all this into one impedance, voltage divide for that, and then once we have the voltage here, we can voltage divide in here. So to combine these all together, the best way to do that is MATLAB. Okay, so adding these in parallel, we have we have 4 plus 4j times minus 4j over 4. That's 4 minus 4j. So we'll call that Z2. Okay, so now we want to voltage divide. So our circuit now, I'll draw this circuit again. We have our 24 volt source here. We have Z1. We have Z2. And we'll call this Vx. Okay, so this voltage we just found is Z2. We know that Z1 is half minus a half J. Find Vx. We goes, we want the voltage over Z2, so we go Z2 divided by Z1 plus Z2. And that's all times 24. So that's 21.3. Okay, so now that we know this is 21.3 volts, we can do another voltage divider to find V0. So that's going to be four over 4 plus 4j. So V out equals 21.3 times 4 divided by, oops, 4 plus 4j. And our answer is 10.65 minus 10.65j. And that's our answer.